Hello, thank you all for joining. So today's session will be about GraphQL explained through performance testing. So what we'll be doing, we'll be looking at GraphQL, of course, some Angular, and of course we also will be doing testing. So who's this for? To get a sense of who's in the audience. Are there any testers in here? Oh, do we have any testers in the audience? No? That's too bad. Do we have any backend developers in the audience? Oh, nice. Congrats. And do we have any Angular developers? Most of you, right? Great, great. So today's talk will, of course, be for all of you. We'll be doing some GraphQL, as I said, some Angular, and most of all, testing. My name is Roy. I'm from Amsterdam, the Netherlands. I work for a company called Stepzen, and I also built my own tool called Reposted. So if you're a developer advocate like myself, you like to repost your stuff on different blogging platforms, you should check it out. But most of all, I spend my time on helping developers to learn new technologies. So I've written some books on React, sorry for that, but also full stack GraphQL, which is using some Angular. So that's fair to be said. You can also find me on Twitter and YouTube with my handle @GetHackTeam. So if you want to stay connected after the conference, make sure to find me there. So what do you already know about GraphQL? Are there people in here that are using GraphQL? Well, some of you. Are there people in here that want to learn GraphQL? That's good. So most of you want to learn GraphQL. So we have the right audience. So that's great. So GraphQL is a query language for APIs. Sometimes I get people asking me if GraphQL is a framework or it's maybe a library, but GraphQL is all of those things. But most of all, it's a query language for APIs. So people are using GraphQL inside their frameworks. GraphQL itself, it's not a framework. It's also not a library, although there are really good libraries that help you build GraphQL applications. So what does this mean? It means if you look on the left, you can see the GraphQL query language. We can see we have a query called GitHub Queries, and as you can see, it's all very declarative. But just by looking at the query, you get a sense of what's doing. So with this query, you can get a user from GitHub, and GitHub has a very nice GraphQL API. You can get its bio, and you also can get a list of the followers of this GitHub users. And if you look on the right, you can see you get exactly the data you ask for. So the format you see on the right is the same shape as what you see on the left. And that's why GraphQL is a very declarative query language. Before even sending your request, you already know what format your data will have, which is one of the great features that GraphQL has. And it also reminds me of the Spice Girls song. If you tell GraphQL what you really want, you're going to be getting exactly that data. So it's good to know if you're looking at a GraphQL query, you can already get a sense of the data it's returning. And this is convenient if you're building your front-end app. Without even sending a request, you know which fields you should add in the UI you're rendering. And another thing it does, it offers a single endpoint for multiple resources. And this is something a REST API, for example, doesn't, which we will also see in the demo I have prepared for you later on. So GraphQL offers a single endpoint, meaning that all your requests will go to one single endpoint instead of multiple endpoints. And through the single endpoint, you can get multiple resources. What does this mean? If you look at this example, it's a GraphQL version of the Twitter API. So Twitter itself, it doesn't offer a GraphQL API, but I've made one for you that's just using the Twitter REST API. You can see we're searching for tweets that are containing the word Einstein. And in there you have a concept called edges and nodes, which isn't as important for today, but GraphQL is all about graphs. So if you know graph databases, edges and node might sound familiar. So let's focus on the data inside the node, which is the created at field, the text field, and also the author field. The way the Twitter REST API works, if you want to get data for the tweets, so if you want to search for tweets, you will get only the tweets. If you want to get the author of the tweet, so the person that tweeted it, you need to send a second REST API, second request to a REST API. So it will have a separate endpoint. So to collect this data with REST APIs, you would always have to collect the information from two separate endpoints instead of just one, which we have in GraphQL. So these are somewhat nested relationships. So you can tie the data together as you often need to use it on the same UI, because probably you also want to display the person that tweeted it whenever you're searching for it. And then something I really like, and which you probably also all like as you're using Angular with TypeScript, GraphQL is based on the type system. So whereas REST APIs typically don't really come with a type system, you sometimes see an open API specification, but more often people forget to make them. Sometimes you have documentation for an API, but people tend to not keep it up to date. With GraphQL you have a built-in type system, meaning that your API documentation is always up to date if you're using the type system. And if you want to explore a GraphQL API, you typically do it through a GraphQL playground. This is an example of one. And in here you can find the type system. So if you would start typing on the left, you will see auto-completion as you're used to from TypeScript. And if you look on the right, you can see the actual documentation. So this is a visual representation of the GraphQL schema. Whereas with OpenAPI, you need to define specification in code, and then hopefully you have someone that wants to render it in something like Swagger. And with GraphQL, this is all built in, so it comes at no additional cost or effort for your team. And of course, every field has a type definition. And this talk isn't about TypeScript, but if you use GraphQL together with TypeScript, you can imagine you can combine these two type systems, meaning that you also don't have to manually type the data that is coming out of your API requests. So GraphQL gives you control over your data from a client perspective. So usually with REST APIs, the backend developers creating the API, they are in control of the data that is returned to your clients. Whereas with GraphQL, you as the end user of an API, you would have control over the data. So by defining a list of fields you want to see, and we'll go more into this later on, you can control what data is being returned. And this all has to do with how GraphQL is working as a query language for APIs, instead of being just something static like REST APIs. And this also improves the developer experience, most of all because you get control over the data, but also because with this type system, you can use and combine it with existing TypeScript applications or the other applications you might have. And besides that, there's a huge ecosystem that is also built on top of this type system. So the playgrounds we saw, they're all part of the GraphQL ecosystem, and people are using this type system to make this all possible. So this type system is one of the main reasons for me to go with GraphQL. There's tons of reasons to go with GraphQL, and if you're on Twitter, you probably saw discussions if you really need it, if your project might be too small or too big for it. But my major reason for using it is actually the type system. So let's start learning how it works, as only a few of you have been using GraphQL, and most of you want to learn it, you're at the right place. And for this, we will be using Angular, of course, in a special React India edition, and we will also be using K6. So K6 is an open source JavaScript tool or library for load testing. With K6 you can performance test or load test, however you like to call it, APIs, but also applications. And this is all open source, so you can use it on your computer. But as you see in a bit, it's also dependent on the speed of your internet. So typically, if you want to do actual performance testing, probably do it in a VM somewhere so you can compare the results, instead of on your computer, which is really subject to the speed of the internet and whatever processes you might have running. So K6, it's pretty cool. It's all JavaScript, so all of you should be able to use it. And for this we also will be using a REST API from Practical Dev. I sometimes write articles on there. Do people know Practical Dev or dev.to? Yes? Okay, great. There's some other cool platforms like it, like Hashnode, which I believe is coming from India actually. And they have a REST API, Practical Dev. Hashnode has a GraphQL API, so I could have also used that. But what I want to do, I'm going to compare the performance tests of the Practical Dev REST API with the performance test of the GraphQL API. So I graphicalize this using StepSend, meaning that with StepSend I can turn every REST API into GraphQL. And I won't be going into the details of how to do this, because today is all Angular, but I'll be sharing a link to a repo later on, and there you can see how it's done. So what I will be doing, I'll be mapping the endpoint to get a list of articles to a query called posts. So this will give you control over the data that's coming from the REST API, and you can also select which fields you like to see instead of getting all the fields in your application. I also graphicalized a endpoint to get articles by its ID, so a single article, and this is a different query that takes an argument, the ID of the post. But then I've done something else, as I told you before. With GraphQL you can also make relationships, you can combine multiple endpoints, like we saw with Twitter, where we combined the searching of all the tweets with the endpoint to get user information. I've done the same for this API, so I took the REST endpoint to get users by their ID, and I've included these into the other two queries. So by using these two queries, you can get a list of articles, including the user that wrote it, and you can also get a single article, including the user that wrote it. So are you ready to see the demo? Yes? Okay, great. So we're going to be doing some demoing, so I'll be typing. If you see something going wrong on the screen, let me know. Maybe you see it first before I will see it. So there, I'm having some code up here. So I set up a small application in Angular that is taking a GraphQL API that was GraphQLized, as we just saw. So let me open up a new terminal and quickly show you the application. So it's a very simple application that shows a list of posts. We have it here. So this is the application. You can see it shows a list of posts. There is a way to search for a subset of posts by username. So this is my username for Practical Dev. And we're not doing much. We're showing the title and we're showing the body of every article. But if we go to the network tab, you can actually see what data is being loaded. So if we would refresh this page, we can see there's a fetch request to a GraphQL API, and as you can see, for every article, we're loading tons of fields. It's a bit bigger. I hope your eyes aren't as bad as mine, but still. You can see we're getting a whole lot of fields. And with REST APIs, typically you will get a whole list of fields in your application that you're not even using. So for this simple homepage, we're only using the ID probably, because it's always good to have an ID. We're also using the slug maybe, the title, and the description. We're not showing whenever the article was created, we're not showing the cover image, we're not showing a publish date, or maybe any other metadata that's inside here. But if for a REST API, you typically would get all this information in there if you're not using GraphQL. And let me show you this in code as well. Let me go here. Clean this up so I have my application next to my code, which is a bit nicer. So we have our Angular application, and what I'm doing here, I mimicked the usage of the actual REST API endpoint by including all the fields. But with GraphQL, we get control over the fields that we're using in our application. So let me show you how that works. In here I've got a query, and the query is being sent to the GraphQL API. But typically we can get rid of all these different fields, as we're not using them and we're not showing them. And if you're just rendering a simple page, you could imagine leaving out these fields. It doesn't really do much harm, right? Because if you look at the bandwidth that we're using here, or is it? Probably if I close this, you can see the time it takes to send this request. You can also see the size. It's only 500 kilobytes. So it's not that much. But imagine having a lot of different users going through your application. And to mimic this, we'll be doing a load test. So let me go back to my code. I've set up case 6. And as I told you, it's a really simple way to test any endpoint. What I've done here, I'm using the HTTP library from case 6, and I'm going to show you something that's called overfetching, which is what we just saw. You get way too much fields in your data because you're not using these fields. So typically you would want to get rid of these fields, and with GraphQL you can get rid of these fields. So let me first use the query that we're using now, which is mimicking the GraphQL and the REST endpoint. So this is the GraphQL equivalent of our /articles endpoint in REST. So we're getting all these fields that we're not using, and if you're doing it just once, it's fine, because it's not that much data. But if we're doing this for a lot of different users, it will be a bigger problem. So with case 6, I can just send a request using http.post. It's very similar to how you would do data fetching in any other application. And to run this, I can run the case 6 command that says run. And let me open a different terminal tab for this. In here we can run the command k6 run. We're going to be using 10 virtual users, so it will be 10 concurrent users that will be clicking away over a time of 30 seconds. And we'll be using this file, which is called k6 overfetching. So first, let's try and see how many requests we can do in 30 seconds for 10 concurrent users once we're getting all the fields, and let's see how much data that would produce. So it will take 30 seconds, and as I said, it's also subject to the speed of the internet. So please put your phone away, and then it might be going a bit better. Because the amount of requests we can do within these 30 seconds time frame depends on the internet speed connection and also the APIs that you're using, of course. So the 30 seconds are almost over, and once this is complete, we will see a list of some statistics, and most of them don't really matter to, well, most people, but some of them are actually interesting to compare. So this is the data that we're getting back. There is some interesting data that we can see, and most of all is data received, 25 megabytes. So in these 30 seconds, we've received 25 megabytes of data, and there were almost 500 API requests. So imagine an even more popular website. Imagine maybe having thousands of requests within 30 seconds, and what data this would produce. We also have the duration speed, and you can see the slowest request was like 4.5 seconds. So it's probably also due to the internet speed not being able to send all these requests at the same time, so we might have some timeouts. And now let me go back to the file. And let me get rid of all the fields that we're not using. So if you remember the application, we were showing the title and the description. So let's just get rid of all the other fields that we're not using in this example, and see how this cleans up, right? So in GraphQL, you only need to define the fields that you need. So by getting rid of all these fields that we're not using, you can probably save a lot of data. So if I save this, and I will be opening a second terminal window, like this, we're going to be running the same command. So again, we're using k6, we're going to get 10 virtual users over a duration of 30 seconds. And we're seeing an error. That's interesting. Let me try and run it again. So let me just go back here and use this same window. That's interesting. Did I delete something? You're all smarter than me, so let me close this terminal. So I'm leaving out something. I deleted this. That's my mistake. Let me delete this, because these are the fields we're not using, and I somehow left out the import of HTTP, which is important as we really need this. So let me scroll up here to our results. It's a lot of scrolling. Well, we remembered it right. We had 25 megabytes of data being transferred in 400. So 25 megabyte data for 475 requests, as you might remember. So let's try and see the difference when we're... Zoom a bit more? Of course. So the previous request, we had 25 megabytes of data and 475 requests in total. So now we're going to try this again with less fields. As with GraphQL, you have control over the fields you're getting. So let me save this and then rerun the k6 command. So now it's all working. We have 30 seconds to spare, so maybe someone has a nice joke that we can use in the meantime. Or maybe not, it's also fine. So now this is the second request, and what we should see less data being used, but most of all there should be space for more requests, because we're getting less data back, so it takes less time to parse, and we should be able to see more and less data. But of course, the more requests we can do, the more data we will receive. If we go to these results right now, you can see the data is only 355 kilobytes. Which is a huge difference, right? Because we saw 25 megabytes whenever we were mimicking the REST API. And now we're using GraphQL, and actually its power of just selecting the fields you need. You can also see we almost, well, not really doubled, but we got 770 requests done in the same time. Because we are sending less data, we're also receiving less data, meaning that we're able to do things better. So this is something what we call overfetching, getting too much data while you only need a small amount of fields. So let me clear this terminal and this one as well. And let me go to a second example that's called underfetching. So with underfetching, it's the same what I showed you for Twitter. We want to get more data than our API endpoint has. So imagine the REST API having two different endpoints, one endpoint to get the posts and another endpoint to get the user of these posts, so the person that wrote it. So this would be the equivalent of /articles in REST, and then this would be the equivalent of users and then a specific user in REST. And with the REST API, you have to make two requests. So what I should do actually, I should separate these and not do them in one request, but in two separate. So we could first do this, save it, and see what happens. But I can probably also try and tie them up. I probably need an async function. So best not to do it now. Let's do it separately. So first, let's get the post. And let's reduce the time, because maybe the 30 seconds are too much, and we only need less to actually show you what's going on. Open up my terminal, and instead of 30 seconds, I'll just be doing this request for 10 seconds. It's going a bit faster and it's still showing the importance. If you're actually doing performance test for your application, you probably want to go maybe by a minute, or 10 seconds might be too slow maybe. What we're seeing here, we have one request that sends 1.6 megabytes of data, and then we should do the other request, which is getting the users, and then we should basically combine them. So with REST, we would have to send these two different separate requests. So what you basically would have in 10 seconds, you would see both requests, but it's a bit hard to tie them together async, otherwise I should have prepared the code. So we have two different requests, and we have 244 iterations and also 237 iterations. So it's almost 500 iterations in 10 seconds. And let's combine them again, which GraphQL does. So with GraphQL, you would be able to get both the posts and the users in one single request. So instead of 10 seconds, we will be running this for 20 seconds. Meaning that we would have the same amount of time, and we can see if we can do more requests with GraphQL. And actually also consume less data, because in the end what we want to do is consuming less data, as this is important. So the 20 seconds should be able to, I don't know, at least get the same amount of requests, or get pretty close. But most of all, we should be transferring less data. Because something I didn't really use here, but with the REST API, of course, you have no control over the fields. So what this actually should be, it should be the blob of fields that we saw before, including all these useless fields that we're not really using. And the same goes for users. And in here you can see we got almost the same amount of fields, but we got way less data. So we got 247, while with the other we got 145 and a bit more, 1.6 megabytes. So it's a huge difference already. So this is what we call underfetching. And in GraphQL, you might even be able to do this, where you don't have separate queries, but you have one query that returns all the information that you need. So these are the relational fields that we have in GraphQL. And by load testing, you can see the result of this, because simply by going to your own browser and seeing the difference, it doesn't make that much of a difference, because you're only one user. But as soon as you ship code to more users, you're going to be seeing the difference in data here. Especially with overfetching, where we went from like 25 megabytes to maybe just 1 megabyte and almost a double amount of requests. And for underfetching, we saw that we could do more requests in the same amount of time and also got less data to handle, just by having the complete control over data and being able to combine these different things. So if I would go back to my presentation. So we saw the code. I hope you all thought this was really cool, because even if you don't like GraphQL, you learned about load testing, so you can even use this for your REST APIs. As case 6 is just using HTTP, so you can put in whatever HTTP API you might have. And there's much more GraphQL can do for you, of course, besides helping you with underfetching and overfetching, so getting complete control of the data. You also get the type system, as I explained in the beginning, which will help you if you're building TypeScript. And of course, all the entire ecosystem of developer tools will then again also help you with making your job a little bit easier. So here's the code, and I'm going to give you like 30 seconds to make a picture of the QR code if you want. The QR code on the left is the Angular application that is using a GraphQL API, and this includes how to set something up with StepSend to GraphQL's existing REST APIs. And what you see on the right is an example of using K6. So it shows how to test APIs and do the performance test we just saw. So with K6 you can define the amount of users and also the time span, and you can make all sorts of combinations to mimic the behavior of users in your application. So let's wait till everyone was able to scan this. And if you follow me on Twitter, I can post these links there as well, so you should be able to get them on your machine. Give it a couple more seconds. Okay, so these will all go to GitHub, and you can just find instructions to clone the code from there. So that was it. If you have any questions, you can find me around the rest of the conference. You can also connect with me on Twitter and ask your questions there. So thanks a lot for your time, and I hope to stay in touch.